Welcome to the School of Life. Life is hard, but you have got to be harder. I am Mrs. Collins, your life coach. Let's get started with Unit 3, Lesson 1, Parent Functions. Our essential question: what are the common features of the graphs of function families? To begin, we'll start off with the definition of function families, or family of functions. It's a group of related functions that share a common parent function. A parent function is the most basic form of an equation. In our class so far, you have at least seen linear functions. Linear functions, we write them as y equals mx plus b in slope-intercept form. We're going to look at how this equation, y equals mx plus b, has shifted or transformed from its most basic form, which would be y equals x. In this unit, we will be using function notation, which is f of x. But just note that f of x is another way to write y. So y equals mx plus b would be the exact same thing as f of x equals mx plus b. But again, going to its parent function, its most basic form of an equation, it would just be y is equal to x. Y is equal to x. So looking at, again, the parent functions of each of our functions here: linear, quadratic, cubic, absolute value, square root, and rational. There are some key things that we're going to pick out and talk about. So first off, we have our linear function. Our linear function, one thing that you should point out is the word line within linear. All linear functions form a straight line. A linear function can be decreasing or increasing. It has a slope and it has a y-intercept. For our quadratics, they could be written in the form f of x equals x squared. Okay, and the key thing here is that our exponent is a 2 for a quadratic. Exponent is a 2 for the quadratic. A quadratic equation or function forms a parabola when it is drawn, and that's that U shape. If the U shape is facing upwards, then it's facing up like a cup. This means that it is positive. So this means that your quadratic, the A value is positive. It also can face down like a frown. And this would mean that our A value is negative. We'll talk more in details about the A value that I'm referring to in a different lesson. We then move on to our cubic function. Cubic functions, the very basic cubic function is f of x equals x cubed. Notice that our exponent here is a 3. So for all cubic functions, the highest exponent will be a 3. Things to note is that it can have a deeper bend. All right, and then as it is formed here, it's increasing from left to right. So from the left to the right, so from left to right, going that way. From left to right, it's increasing, it's going upwards as we're again traveling from the left to the right, we're going up. This is positive, but you can also see if this was shaped this way, then going from left to right, so this is left, going towards the right, it is going downwards. We would show that this means that it is decreasing. So just note that we will talk about this in detail when we get to these specific little lessons. So we've gone over linear, quadratic, and cubic so far. These are just different characteristics that each of these functions have. If we move on to our absolute value function, the parent function is f of x equals the absolute value of x. These brackets here means absolute value. Absolute value. Absolute value is a number's distance away from zero, which again, we'll talk about that as we get to the specific lesson on absolute value. But in the very basics, we have that this absolute value function is always graphed as a v. And it should be noted that it can also be upside down. And we'll talk about what causes it to turn upside down. So you'll also see absolute value equations turned upside down. All right, then we move on to our square root function. Its parent function is f of x equals the square root of x. And in this particular case, it is pictured as just having one arrow. So square root functions only have one arrow. Next, we have our rational functions. The parent function is f of x equals 1 over x. And it should be noted that a characteristic here is that it has two branches. And those two branches are in quadrants. So if you can recall, quadrant 1, 2, 3, and 4. In this case, we have two branches here and here, and they're in two different quadrants. And we'll talk about more characteristics for those rational functions as well. Okay, the main takeaway for this lesson is just knowing what each of the graphs look like. So for a linear function, it's a straight line. Quadratic, it's U-shaped. Cubic, we have this like curved, it's almost like a saddle shape. Absolute value, it's a V shape. Square root only has one arrow. And then rational, we have like these two branches in our different quadrants. So again, the takeaway is to know what the picture, or looking at the picture, which of the function families it belongs to. An additional thing that you'll need to know within this particular lesson is how to calculate the domain and the range. So domain and range, which should be familiar terms to you, but we'll go over them again within this particular unit. So the domain refers to our x coordinates that we have. Our thinking point will be, if I extend the graph far enough, can I reach the left and right edge? And are there any places on the x-axis that I cannot touch? Your range refers to all the possible y coordinates you can have. And you're going to think, if I can extend this graph far enough, can I reach the top or bottom edge? And are there any places on the y-axis that I cannot touch? And we'll put that into action on the next page. The last big takeaway that we will need to understand for this lesson, as well as for this unit, will be about end behavior. So as far as end behavior, every line has two ends, the left side as well as the right side. Each side will be either going up, down, or straight across. Every line has two end behavior statements. So first off, looking at our coordinate plane, we have a side where our x values are positive, and then we have our side where our x values are negative. We have a side where our y values are positive, and we have a side where our y values are negative. So Just think about your coordinate plane and think about where the x's are positive versus negative, as well as for the y's. If, for example, we have the following. It says on the left side meaning over here where the x's are negative. So where our x values are negative, the line goes up. So if we have over in this region on the left side where our x's are negative, we have some line whereas the arrow is pointing upwards, then that means that our function is going towards the positive y values. So it's going towards the positive y values. In order for us to write that as a behavior statement, we'd write as x is going towards negative infinity. Our y's are going towards positive infinity. So as x's are going towards negative infinity, y's are going towards our positive infinity. And this infinity just means as the x's are getting smaller and smaller and smaller and smaller and smaller and smaller, our y's are getting bigger and bigger and bigger and bigger and bigger. Okay. Another example, on the right side. So on the right side, here's the right side. That's where x's are positive. So as x's are positive, our line is going downwards. So if we're here, as our x's are positive, and we see that our line is going down, that means that it's going towards the negative y values. And if it's going towards the negative y values, then our statement is going to be as x is going towards positive infinity, our y is going towards negative infinity. Okay, so as the x's are going towards positive, the y's are going towards negative. One key thing to note, all of your statements will be starting off like this. As x goes towards negative infinity, comma, y goes towards blank, and we'll be responsible for filling in that blank. The second statement will always start off as x goes towards positive infinity, the y goes towards blank. Okay, so we'll always be filling in this last part. First part will remain the same as x's are getting smaller or as x's are getting bigger. What's happening to our y's? So we have some examples here where we're asked to identify the domain, the range, as well as the end behavior. We start off with number 1 and we look at our graph. In number 1, we have the graph of a line. So if you think back to the families, whenever we had a graph of a line, that meant that this particular family is the linear family, or it's a linear function. So this is a linear function. When we're thinking about the domain, remember that the domain has to do with the possible x values. So the possible x values. So as we, or if we, were to extend this graph to the left and to the right, so notice the arrows here. If this was to continue towards the left, and if this was to continue towards the right, then what we're going to do is look at all of the possible x values that it's going to cover. So one thing that I like to do is kind of envision this being bounded somehow. Okay, so looking at it from the left and looking at it towards the right, but noting that this arrow is pointing upwards. So technically this line here is going to constantly move outwards. So it's going to constantly be going this way. It's going to constantly expand. And this line will constantly expand this way. So what this is saying is that, well, so far I can see that I'm covering all of these x values, all the way from this 2 through this -5 here. But because we have these arrows here, this red highlighted line is going to constantly move outwards. So it's going to constantly cover more and more negative x values. On this side, because we have our arrows here, our x values that will be covered are going to constantly get bigger and bigger because we're going to constantly move this line as well. So when we're thinking about, well, which x values is this line going to cover, it's going to cover all of them. And we say then that means all real numbers. All of the real numbers will be covered. And that's our domain. All of the x values, every single number on the x-axis will be a part of creating this line. Moving on to our range covers all of the possible y values. And so in this case, if we were to look at the top and the bottom of this particular graph, again, noting that there are arrows here, so it constantly goes upwards and it's going to constantly go downwards. If we were to kind of box in the region for where it starts and stops, so starting down here and stopping up here, but not really, noting that there's arrows here. So constantly, this blue line down here is going to constantly be moved further and further and further down. This blue line up here will constantly be moved further and further up. And because of that, you can think about crossing over all of the all of the y values that are all within this particular region. Okay, but again, noting that that bottom and top blue line are going to constantly move up and down. So that means that all of the y values that are covered in this region will be a part of our range. But if this top line is moving up and up and up and up, that means that we're going to constantly go with or have more y values in our range. Same with the y values at the bottom. If this bottom line is constantly moving downwards due to the arrows constantly moving us downwards, then we're going to constantly go over y values that are smaller and smaller and smaller and smaller and smaller, and it won't stop. We're going to eventually cross over all of the y values on the y-axis. So therefore, our range will also be all real numbers. As for end behavior, remember we have our end behavior statement. To start off with, as x is going towards negative infinity, what's happening to our y. And the other one will be as x is going towards positive infinity, what's happening to our y. So again, we always start off just like that. So let's begin. As x is going towards the negatives. So this is x going towards the negatives. As x is going towards the negatives, well, our line is going up, 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 and it's going up towards the positive y values. So this is going towards positive infinity. As we do the next one, as x goes to positive infinity, so that's x's and your positives. So as x is positive, notice our line is going down, 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 and it's going down towards the negative y values. So it's going towards negative infinity. And that's our end behavior statement for number 1. For number 2, if we go back and look at our families and the pictures that identify the families, this one, it looks like a saddle. This one is our cubic function, and it belongs to our cubic family. As for the domain, noticing that we have an arrow down here at the bottom and an arrow up here at the top, this graph is going to continue going down and it's going to continue going up on this right side. As it continues going down, it's going to continue to cross over all of the x values. And as it continues to go up, it's going to incorporate all of the x values on the right-hand side. So the domain will be all real numbers. As for the range, because it's going to continue going down, 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 and up, 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 it's going to cover over all of the y values as well. The range will be all real numbers. As for the end behavior, it starts off the same as x goes towards our negative infinity. What's happening to y? And as x goes towards positive infinity, I'll write that positive infinity a little better. What is happening to our y? So as x is going towards the negatives, so here are the negative x values. Well, in the negative x values, our line is going downwards. So it's going down towards the negative y's, so negative infinity. And for the other one, as x goes towards positive infinity, so here's the x's that are positive. On this side, our line is going upwards towards our positive y values. So it's going towards positive infinity. We have number 3. Number 3, our graph is U-shaped, and the function family that is U-shaped is our quadratic family. So this is a quadratic function. As for the domain, again, that's dealing with the x values, all of the possible x values. So we want to know what possible x's will be used to form this shape. In this case, note that you're going from the left to the right. As we go left, 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 and as we travel right, 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 we're going to end up traveling over all of the x values. So therefore, our domain is all real numbers. As for the range, that deals with the possible y values. And this one is a little different. We're looking from the bottom of our graph, to the very top of our graph. So bottom to top. In this case, we have at the top these arrows, which says that this graph is going to continually grow. But for the bottom, we stop and we don't go any further past this -4 for our y values. So all of our y values are going to be y is greater than or equal to the -4. We'll have to use an inequality for it to represent all of the y values that we're going to cover for this particular graph. So y is greater than or equal to -4. The bottommost points on this parabola has a y value of -4, and all of the other y values are way higher or higher than -4. For our end behavior, again, it starts off the same. X as it goes to negative infinity, y goes towards, and we'll fill in that blank, and x as it goes towards positive infinity, y goes towards, and we'll fill in that blank. So starting with the first one, as x goes to negative infinity, so x is on its negative side. So on this negative side of our x's, we are going up, 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 and we're going up towards positive y's. So then this is positive infinity. As x is going towards positive infinity, so that's x's towards the positive. What's happening with our graph on this side? We are going up, 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 and we're going up once again towards the positive y values. So this is also positive infinity. All right, in triangle number 4. Number 4, we have a graph, and that graph is V-shaped. Our V-shaped graphs belong to the absolute value function family. The domain here, again, that deals with our x's. In this particular case, we're looking from left to right. Notice our arrows here is going to constantly extend our graph further and further and further left and further towards the right. We're going to be covering all of our x values on the left and all of our x values on the right. So therefore, our domain is all real numbers. As for our range, it deals with our y's. And so we look from top to bottom. At the top, our top of our graph extends from our y value of a 2. And the bottom of our graph, it doesn't stop. So there's like no line that we could draw towards the bottom because it's going to keep going down, down, down on the left and down, down, down on the right. So it's going to cover all of the y values that are less than this 2. So then we will write our range as y's are less than or equal to that positive 2. For our end behavior, we start off the same. As x is going towards our start off with negative infinity, what's happening to the y's? And as x is going towards our positive infinity, what's happening to our y's? So let's start it. As x goes towards the negatives, so here's the x's in the negative. What's happening to our graph? We are going down, 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 and we're going down towards the negative y values. So we're going towards negative infinity. And as our x's are going towards positive infinity, so the positive x's, our graph is once again going down, down, down towards the negative y values. So we're going towards negative infinity. All right, so we have a couple of U-try problems. Number 5, you are to find or figure out which family this function belongs to, the domain, the range, and the end behavior. Let's see how many you can get right. All right, and the answer for number 5. This function belongs to the cubic family. The domain is all real numbers. The range is all real numbers. And as far as the end behavior, as x goes towards negative infinity, so as x's are in the negatives, our graph is going up, up, up towards the positive y values, so towards positive infinity for y. And for the other one, as x is going towards the positives, our y's are going down, down, down towards the negative infinities or negative y values. So that's going down towards negative infinity. Let's look at number 6. Pause your video and try number 6. All right, and our answers for number 6. Our graph belongs to the absolute value family. The domain is all real numbers. Our range is y is greater than or equal to 1. And our end behavior, as x is going towards the negatives, our y's are going towards the positives. So as x's are going towards the negatives, our y values are going towards the positives. And as our x's are getting positive, our y values are also going towards the positives. So here's our end behavior statement. If you have any questions about this lesson, please feel free to ask.